Imagine a horse you can ride that never needs hay, doesn't spook at traffic, and drinks only water. Meet CORLEO. From that instant I'd keep the energy rising and speak as an engineer explorer who's seen the prototype move. Kawasaki Heavy Industries, drawing on its motorcycle, robotics and hydrogen energy divisions, created CORLEO as a concept for a new class of off-road personal mobility that looks like a bionic horse but behaves like a carefully tuned machine. Kawasaki designed and developed CORLEO by combining its vehicle dynamics know-how with robotics research and clean energy specialists to build a four-legged, rideable concept that preserves the joy of riding, while adding terrain adaptability and rider safety through sensors and AI. The concept was unveiled to the public at the Osaka Kansai Expo in April 2025 as part of Kawasaki's showcase of future mobility ideas. It's not an overnight invention. The design pulls together decades of Kawasaki motorcycle chassis and powertrain experience plus recent advances in quadruped robotics and hydrogen fuel cell technology, presented as a concept prototype rather than a production vehicle at the expo. The public reveal and demo footage in spring 2025 are how most people first saw the machine walking and cantering through display environments. At its core, CORLEO is a two-seat, four-legged rideable robot with features aimed at all-terrain travel. A hydrogen fuel system, a fuel cell that generates electricity from hydrogen, an electric hybrid drive architecture, AI for balance and terrain recognition, inward-facing knee joints and adaptive rubber hooves that absorb irregularities, a rider interface with head-up display and ride feedback, and night path projector lighting for low-light navigation. Kawasaki's materials and structural choices are engineered to combine lightness, strength and shock absorption so the machine can carry people off-road. Reports in Kawasaki's concept page emphasize the blend of motorcycle handling and quadruped stability. Structurally, CORLEO's body follows a bionic-inspired layout, a central chassis that houses the fuel energy system and rider cockpit, four independent leg units with multi-axis joints and suspension, and cloven, rubberized hooves designed to be slip-resistant and absorb surface shocks. Kawasaki describes the leg units as having front and rear leg assemblies that can move semi-independently to smooth shocks and keep the rider stable. The visible surfaces appear to mix high-strength alloys and composite panels where weight savings and impact resistance matter. While Kawasaki hasn't published a full materials bill of materials, the concept's visuals and press materials point to a mix of metals for load paths and actuators, and composites or engineered polymers for bodywork and impact zones. How it works. CORLEO uses a hydrogen energy source to power onboard electrics. Reports describe a hydrogen fuel cell system feeding electric drive for actuators and motors. A suite of sensors, cameras, lidar, inertial measurement units and pressure, force sensors in the leg joints and hooves, feed an AI control system that